Hello, third period, Mr. Rivers here. I am out today, so I've created a video lesson for 8.5. Just like we always do in class, we take notes in OneNote. So please watch with your full attention and take notes in OneNote. And we also have homework associated with this, so if you finish the notes early, please start the homework. 8.5, three theorems involving proportions. First off, the side splitter theorem. If a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the sides proportionally. So here we have side DE parallel to side BC. So a line is parallel to one side, right? So DE is parallel to BC. So that means DE is going to divide this triangle up proportionally, divide the sides proportionally. So there's a couple ways we can write this. We can write top over bottom. That'd be like A over B, right? A is on the top, B is on the bottom, is equal to top over bottom, C over D, right? C is on the top, D is on the bottom. Okay, so that's one way that this is divided. The other way this is divided is you might go left over right. This also works. A over C, right? Left over right is equal to B over D, left over right, B over D. So either of these proportions works when there is a line parallel to one side of the triangle. Okay. This does not work with E and F. Be very careful here. A lot of people will say, okay, well, if I'm going to solve for E and F, they'll say A over B, that's like top over bottom, is equal to E over F. Now think about why that might not work, right? Why does this not work? Well, A is the entire side of AD, so that's good. But B, this is not the entire side AB. So A is the whole side, but B is a partial side. And then E is the whole side, but then F is also the whole side. Compare that to C over D, right? C is the entire side of AE, but D is not the entire side of AC. So if you wanted to set up a proportion with E and F, here's how it would look. Well, let's start with this. E over F, right? That's the smaller triangle side over the larger triangle side, is equal to, well, smaller triangle side is A, over the larger triangle side would be this whole side here. So what would the length of AB be? Well, it'd be A plus B, A plus B. So this would be a proportion you would have to use. Now, if there's numbers in here, it'd be a lot easier than just variables that, we don't know what they are yet. So you're probably looking at it, you're like, oh, A plus B, I've got to use the distributive property when I cross multiply and solve. Keep in mind when there's numbers here, it's a bit easier. And we actually had a problem like this, I think it was yesterday, where we had like 16 plus x or something like that, and we did have to cross multiply. So this is not totally foreign to you. The new part of this is the side splitter theorem, which is top over bottom, A over B, is equal to top over bottom, C over D. Or left over right, A over C, right there, is equal to left over right, B over D. B over D. Okay. So pause the video now and try example 1 on your own. Okay, so if I start with x, x is here in the top right. So I need a proportion with x in it. Well, one that we can come up with is this. Top over bottom, 15 over 20, is equal to top over bottom, x over 18. Now you may have gone left over right, which means you might have had 15 over x equals 20 over 18. That would also work. By the way, I should also add that right over left works, right? X over 15 equals 18 over 20. That would work. You could also go bottom over top. 20 over 15 is equal to 18 over x. So any of these work. So now let's cross multiply and solve. I'm going to pause the video and do this now. So we cross multiply and solve. X times 20 is 20x. 15 multiplied by 18 is 270. We divide both sides by 20, and we get x equals 13.5. So now let's work on finding y. Remember, y is the entire side, so we can't use the side splitter theorem to find y. We'll have to go small triangle over larger triangle. The whole side of the smaller triangle over the whole side of the larger triangle. So this whole side here on the right, 20 plus 15, that's 35. So I'm going to say smaller triangle 15 over its corresponding side in the longer triangle, which is 35, is equal to smaller triangle side of 16 over the larger triangle side of y, right? So 16 and y are corresponding. Let's talk about why they're corresponding. I kind of didn't mention that earlier. These are parallel, right? So if those are parallel, then we can use the side splitter theorem, and we already did. But also we know that we have corresponding angles here and here, and we have corresponding angles here and here. So we know this smaller triangle and this larger triangle, they have to be similar to each other. And if they're similar to each other, we can set up proportions with the sides and solve for missing side lengths. So now we cross multiply and we solve. It looks like this. 15 times y is 15y. 16 multiplied by 35 is 560. So when you divide this out and you get a decimal, it's 37.3 repeating, which you might say is 37 1/3. Or your calculator can actually convert this to a fraction too. We've shown you how to do that in the past. I've shown you how to do that in the past. And we get 112 over 3. So any of those work for y. Okay, so moving on. Example 2, pause the video now, try this one on your own. Okay, so we can use the side splitter theorem again because we have a triangle with a side parallel to it on the interior of the triangle like this. So I'll do top over bottom. You don't have to do top over bottom. You can do left over right, bottom over top, whatever. But I'll do top over bottom. 2x plus 3, that's the top here, over bottom, x plus 3 is equal to top 3x plus 2 over the bottom 2x. Okay, so now we cross multiply and solve. Remember to use the distributive property. Ooh, and we have a tough one here. We're going to have a quadratic, I think. So 2x multiplied by 2x plus 3. Remember, we have to use the distributive property here. We'll do that in a second. Also, x plus 3, that's a binomial. It needs to stay in parentheses. Multiplied by 3x plus 2. 3x plus 2. Think back to what we have to do when we multiply a binomial by a binomial. We have to FOIL. All right, so first off on the left side, 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x multiplied by 3, well 2 times 3 is positive 6x equals, okay, on the right side here, FOIL first, x multiplied by 3x, that's 3x squared. O stands for outside, x multiplied by 2, that is positive 2x. Inside, 3 multiplied by 3x, that is positive, 3 times 3 is 9x. And then last, 3 multiplied by 2, that is positive 6. So now, think of what we need to do here. We need to, everything on one side. With quadratics, we set it equal to 0. So we subtract 3x squared from both sides, right? We subtract 3x squared, and we're left with x squared on the right side. Let me do this in blue. I'll do it over here too. So we subtract 3x squared from both sides. 4x squared minus 3x squared. We're left with just x squared, right? And let's keep bringing everything over to the left side. So 2x plus 9x, that's 11x. So we're going to subtract 11x. 6x minus 11x, that's negative 5x. And then finally, positive 6, we need to subtract 6 from both sides. Well, there's no 6 to combine on the left side, so we subtract 6. And now we're equal to 0. Okay? So we have a quadratic. We're looking for two numbers with a product of negative 6 and a sum of negative 5. Well, if we have a product of negative 6, we know that one of the terms has to be positive, and we know one has to be negative. That's the only way we can get a negative product. And the one with the larger absolute value has to be negative. Okay? And they're going to be 5 apart, right? So x minus something, x plus something, equals 0. Well, it's going to be negative 6 and positive 1, right? Negative 6 multiplied by positive 1 is negative 6. Negative 6 plus 1 is negative 5. So there we go. We have factored this. All right, so now let's solve. X can equal 6 or x can equal negative 1. Now think to yourself, do we need to test this for whether they are extraneous or not? What does x represent? Well, it's going to be a part of a side length of a triangle. So as I look at negative 1, I'm immediately suspicious of negative 1. Let's plug in negative 1 and see what happens. And right away I see here, 2 multiplied by negative 1, that's negative 2. So that's going to be extraneous. X cannot equal negative 1. So let me make a little note of this, and let's write the word extraneous. Okay, now x equals 6. It should be good. Let's check it out. 2 times 6, that's 12. 3 times 6 is 18, plus 2, that's 20. That's good. 2 times 6, that's 12, plus 3 is 15, and then 6 plus 3 is 9. That's good too. So good. We are all set. X can only equal 6. There are some situations where negative numbers can be, don't have to be extraneous. It just depends on these values of x over here. And there's also some situations where positive values are extraneous. So if it represents a side lengths have to be positive. Just make sure you plug it in and check. All right. All right, this transversal theorem, very similar to the execution of the side splitter theorem. If 3 or more parallel lines are intersected by 2 transversals, then the parallel lines divide the transversals proportionally. So, same idea. We can set up proportions here. Top over bottom, that'd be A over B. A over B, that's top over bottom. A over B is equal to top over bottom, C over D. C over D. There you go. Or you might say left over right. Okay. So like A over C. A over C is equal to left over right, B over D. B over D. Or you could do right over left, or you could do bottom over top. Any of these work. So there's 4 possible proportions that work here with this transversal theorem. So again, if 3 or more parallel lines are intersected by 2 transversals, then the parallel lines divide the transversals proportionally. So pause the video now, try example 3 on your own. All right, well, we got 1, 2, 3 parallel lines crossed by 2 transversals. We can use the transversal theorem. Here we go. I'm going to go left over right. You may not have done it that way. That's okay. 15 over 8, that is left over right, is equal to left over right on the bottom side, 12 over x. 12 over x. And if you have a different proportion than me, that's okay. You're going to see that it ends up being the same as mine if you did it correctly. 12 times 8, and I get 96, right? So 15 times x is 15x. When we cross multiply, 8 times 12, we get 96. Divide both sides by 15, and I get x equals 6.4, or you might say 6 2/5. There you go. On to example 4. Given that AD is parallel to BE is parallel to CF, and AB, let's label this, AB is equal to 4, BC is equal to 6, DF, ooh, be careful here, this is the entire thing, right? DF is equal to 12. Find the length of DE and EF. So be careful here, especially with DF. Pause the video now, give this one a try on your own. So here's one approach to it, right? This whole side here is 4 plus 6, which is 10. So we could treat it like we would triangles, right? So we'll say, let's see here, we're trying to find DE. So I'll say DE is x. Well, what does DE correspond to? DE corresponds to 4, doesn't it? So here's what we'll do. We don't know EF, so we can't use the transversal theorem right away. So I'll do 4, right? That's AB, over this entire segment here, AC, which is 10, right? So we'll call it like short over long. That might be a good way to say it. And then that is equivalent or proportional to x, right? Because x and AB, they're corresponding. X over 12, right? Short over long, x over 12. And now we cross multiply and solve, and we get 10x equals, let's see, what was that? 48, right? 48. Oh, 10x, excuse me. 10x equals 48. We divide both sides by 10, and we get x equals 4.8. X equals 4.8. So let's write that in there, 4.8. All right, now I'm going to use the transversal theorem. We're looking for EF. I'll call this Y. I'll work it in red. Top over bottom equals top over bottom. 4 over 6 equals 4.8 over Y. 4 times Y is 4Y equals 6 times 4.8, 28.8. Divide both sides by 4, and we get Y equals 7.2. Okay, so there you go. There's the length of Y, or EF, I should say. And let's change that from, let's say DE. Hang on a second. Let's say DE equals 4.8. Okay, and then let's hop over here, and instead of saying Y equals 7.2, we'll leave that, but we'll say EF equals 7.2. There you go. That's a little bit better answer there. Okay. Now there's a couple other ways you could have done this one. If you did it a slightly different way, that's okay. If you got the right answer, you know, as long as you support your work, I'm okay with that. So this is not the only way to do this. You might have thought about it in terms of like percentage of the total length, right? So like 4 is 40% of AC. So like DE would have to be 40% of 12. And the same thing for EF, right? You might have thought like, okay, well, BC is 60% of AC, so Y has to be 60% of DF. And you might have also said, okay, well, if this is 4.8 and this is 12, I can just say 12 minus 4.8. I bet most of y'all did that one instead, but I did want to show you the transversal theorem at play here in this problem. So there's many ways to find the answers to this problem. On to the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the adjacent sides. So this one's kind of wordy. First off, we need to know that this angle A here has been bisected. That was not given to us on this. So if we say if angle 1 is congruent to angle 2, that means the angle at vertex A has been bisected. Angle BAD in this case. So if angle 1 is congruent to angle 2, then we're able to conclude that left over right equals left over right. So by that I mean, let me put some letters in here to help us out here. Let's call this A, B, C, and D, right? So A is the length of AB, B is the length of BC, C is the length of CD, and D is the length of AD, all lowercase, right, to distinguish them from the vertices. So then we'll say left over right, that'd be A over D is equal to left over right, B over C. B over C. Very good. So that's the triangle angle bisector theorem. We have to have this angle bisected, right? We have to know in this case angle 1 is congruent to angle 2. Try example 5 on your own using the triangle angle bisector theorem. Okay, so there's a few ways to set this up. If you don't set up exactly like me, that's okay. Left over right, x over 30 is equal to left over right, 14 over 24. We can use the triangle angle bisector theorem because this angle here is bisected. So that means that ray is dividing our triangle up proportionally. We then cross multiply and solve. When we cross multiply, we get x times 24 is 24x. 30 multiplied by 14 is 420. We divide both sides by 24, and we get x equals 17.5. On to example 6. It says if angle 1 is congruent to angle 2, let's label that. Angle 1 is congruent to angle 2. Find the value of x. Try this one on your own. This is also the triangle angle bisector theorem. Pause the video now and give it a shot. So left over right, 12 over 18 is equal to left over right, x plus 3 over 2x plus 1. We cross multiply. Be careful, you got to use the distributive property. 12 times 2x plus 1 is equal to 18 multiplied by x plus 3. Distributive property, we get 24x plus 12 equals 18x plus, what is that going to be, 54, right? 54. All right, nice, no quadratic, right? So we get 6x equals, subtract 12 from both sides, and that is going to be 42, so x has to equal 7. Okay, there you go. All right, thanks so much for watching. Make sure you complete the homework assignment 8.5. Take care.